Hey everybody, in this video we'll talk about graphing a hyperbola given its equation in standard form. So I talk about graphing a hyperbola centered at the origin in a previous video, so you can go ahead and check that one out if you'd like. We're going to follow the same steps that are talked about in that video. Let's see here. Okay, got my color. Take a look at this standard form. The negative is in front of the y squared over 9, which means the 25 is our a squared. So a squared equals 25, which means a equals 5, b squared equals 9, or b is equal to 3. The center is at hk always. H is attached to the x, so h is -3 and k is 0. So we're going to have a center at -3, 0 right there. Okay. Again, why is it -3? Because we need x minus h. In order to get x plus 3 into something with an x minus, what do? We subtract -3. So this -3 becomes our h. Okay, so there's our center. Now we can plot the vertices. Before we plot the vertices, we need to decide if it's going to open sideways or if they're going to be up and down. In this case, our a squared is over our x piece, right? Or our x squared part, which tells me it's going to be opening sideways. So onto the center, in order to get to our vertice, we're going to add a to the x part because we're moving in the x direction. So I'm going to take -3 plus or minus a to find my vertices, which happen at 2, 0, and then -3 minus 8 is -8, 0. So my vertices are at 2, 0, then -8, 0. Now, in order to more easily graph my asymptotes, what can I do? Well, from the center, I go out a already to my vertices, and then in the other direction, I'm going to go out b. b is 3, so I'm going to go 1, 2, 3, and I'm going to draw this box that has a length of 2a and like a width of 2b, and that kind of gives me the slope and an easier way to find or graph my asymptotes. Again, I talk about all of this in more detail in another video. And then my asymptotes, I start from my vertice, and I'm going to go up b and over a, and I'm going to end up at the corner of this box anyway, so I can just draw my asymptotes through the center and then the corners of these boxes like this. And remember, these are lines, so they do go on forever in both directions, so I should add that there. So there's my asymptotes. And then from my vertices, I go ahead and I draw in my curves because they're going to start approaching those lines like that. So there's one example of graphing an equation in standard form. Okay, so now let's look at this problem. We have y squared over 25 minus x minus 5 squared over 16. So the positive fraction is the one with y squared, but in this case we have a squared equals 25, and the a squared is under the y, which means we're going to be opening up and down like this. Okay. Now, the 16 is our b squared, so b squared equals 16, which means a equals 5 and b equals 4. What's the center? The center is at hk. H happens to be 5, and k is 0. So we're going to be at 5, 0 for this one. our vertices are going to go up and down from that center. So our y value is going to be affected. So we're going to take 5, and then our y value is 0, and we're going to add and subtract a, which happens to be 5 as well. So our vertices end up at 5, 5, and then 5, negative 5. Like this. Now that starts our box. Okay, that is the length 2a. And then to find the length 2b, we go from the center, we go out b, which is 4, and to the left b, which is 4, and then we go ahead and we fill in our box like this. Now this, again, this little box is just to help us find our asymptotes. Go ahead and we fill in our asymptotes like this. Now in the last problem, I kind of did everything one color, but I want you to see something on this one. These are just asymptotes, right? They're kind of like guides. Oops. Let's undo that mess there. Okay, so these are just like guides, but the actual graph of the function is this vertex and then the curve that ends up following the asymptotes. Like this. But the asymptotes are very important guides that help us know what the behavior of that curve is. So that's graphing a hyperbola given the equation in standard form.